I'm currently working on my second Mandalorian armor, and in this multi-part series I'll be documenting everything from start to finish and show you how you can create your very own armor using a 3D printer and finish it with graphite powder to give it an awesome Beskar look. This is the helmet from the first build. I finished it with chrome spray paint. I was happy with the results, but I wanted to bring the next costume to the next level, so I tried out graphite powder. This kidney piece is from the new build and I finished it with graphite powder. I really love the results. It's looking much more like Beskar. It's darker than the chrome spray paint here. It's still shiny, it's still reflective, and this is what we're going with for the new build. In this very first video, however, we'll start with a general overview of the project. I'll show you where I got my 3D files from, how I scaled them, and finally got them to print. Furthermore, I showcase all the components that I've already printed, including my old armor. So without further ado, let's just jump right in. Let's start with the 3D files first, because that's the thing that we need before we can start the project. There's a multitude of websites where you can get your 3D files from. One of them is Thingiverse, it's the most common one. Another one is my mini factory, as you can see here, and obviously Etsy. This is the helmet that I used for my first build. It's free, it's awesome, it's on my mini factory made by robpauza. Go grab this one if you like it. It comes in different versions, so you can fit it on any print bed. Another free option is on Thingiverse. That's the helmet from the Broken Nerd. Also a very great helmet. Printed this one too. It's great. Nothing to complain. For the new build, however, I'm going with the GreatApeStudioArt helmet. This is supposed to be the crown jewel of all helmets. It printed beautifully. I love it. And if you can afford it, go buy this one. I can recommend. For the rest of the build, I'm using a mixture of different models from different makers. Moesizzlac has a package with his whole armor inside. However, I'm only using some parts of his. I'm using the shoulders, the gauntlets, and his jetpack. And for the jetpack, I did customize the thrusters so you can fit in smoke machines inside. Go grab those two. They're on my Thingiverse side. I'm gonna link those in the description below. For the chest, abs, kidney and hip armor, which I showed you in the intro, and the thigh armor and also the Greave and knee armor, I use the ForgeMaster props. Also on Thingiverse, very screen accurate, good models, go grab those. The blaster is from Streaker's Armory. It's the blaster here. I already did this for my very first build and I love it. It fits perfectly at 100% into my holster. And finally, the Darksaber is from Adafruit, also free. I also have a description on how to assemble it, but we will get to that in another video too. So we got the 3D models. Now how do I scale them? How do I make them fit my body perfectly? In my case, I figured out that a mixture of Armor Smith Designer and EM3D works best. Armor Smith Designer is a tool which allows you to measure your body, put in the values, and end up with a 3D model of yourself, on which then you can attach the 3D files, scale them, manipulate them, and finally export those. EM3D is a mobile device app which allows you to 3D scan objects. I use it to 3D scan my head, exported this, and then use it as a reference to scale up and down helmets to make them fit perfectly. Here we are in Armor Smith Designer. Once started, you will see this avatar creation window, which will walk you through all these steps and measurements that you gotta do in order to end up with a 3D model of yourself. All you need is a measurement tape and you will be good to go. Once done with the measurements, you will end up with an avatar like this. All you need to do is to import your 3D files. I've already imported the abs and chest plate. Then you can simply attach those. Let's start with the chest plate. Once pressing attach, you will see different nodes here where you can attach stuff to. So we're gonna simply select the one at the front of the chest and then position things just where they should be. And we can already tell this chest piece is too big. Now, Armor Smith Designer comes with different scaling options. You have the uniform and non-uniform, which is similar to the non-uniform and uniform scaling in Cura. But we also have the free form deformation, which will basically generate a box around your 3D model on which you can select faces to manipulate it. You can pick a point and then manipulate it there, scale it from there, bring it up, down, back a little, just to make it fit better. Or you can just pick lines, and you can also pick multiple lines like a triangle here and manipulate it from there. But what I usually do is simply using the uniform scaling because it worked really well. So let's go ahead and scale this chest plate a little bit down. And we can already tell from the size, it looks pretty good. Let's give it a better positioning, like how it should sit in real life. So this is somewhat how the chest will sit. And we can go and attach the abs now to the front of the belly. Scale this down a little bit. And then position everything just how it should be. And that's it. That's basically my workflow here in Armorsmith. For every other piece of the armor, it's the same process. It's rinse and repeat. I import them, attach them to the avatar, scale them, position them up until I'm happy. Once I'm happy enough, I will simply select those here in the right side, export them, they have the right measurements, and bring them into Cura, slice them, and finally print those. Another cool option that Armorsmith Designer brings is the edit pose option up here. You can simply select a body part, move it around, and see how the avatar interacts with the objects and how the objects interact with each other. So you could technically see potential pinch and friction points. However, it's not always as realistic as it would be in real life. This is the reality check. I've already printed the chest and the abs piece that I've scaled in Armorsmith, and they fit me perfectly. I only used uniform scaling. Maybe if freeform deformation works better for you, you gotta test around, you gotta figure it out yourself. Another thing that you've seen is once I moved the avatar around, the chest piece wanted to move above the abs completely. However, this is simply not possible for me because I have attached those pieces together with belt buckles, so I have an automatic stop in here. This is something that you gotta look out for. Another thing that you gotta look out for are pinch points and friction points. Sometimes you can get a sense of where those will be in Armorsmith. However, sometimes you don't see them in Armorsmith, and once you've printed the parts and you wear them, you're feeling some pinch and frictions. This is something that is pretty normal and you have to work around with after you've printed the parts and wore them and tested them. This is the EM3D app, which allows you to scan yourself. It's an iPhone app. It uses the front camera to 3D scan objects, in my case myself. Once started and once start to scan, you will see it's gonna fill your body with these green dots. And once they're solid, you can already tell that this is going to be a good model. Doing it by your own is really, really hard because you have to get the whole head inside and you have to move 360 around yourself, which is really hard to do with your arm. Keep the same distance and keep your head in the center. So what will happen is you will lose tracking. Now there's only two options I found out to do this. One option is you get somebody else who is scanning you. Another option is you get a mobile phone stand like this or a tripod, fixate it to your desk, sit on a chair and turn around slowly in the camera. But even then you have to take the tripod or the mobile stand and move it above your head to get the whole head inside. Ultimately, you will end up with a 3D scan of yourself, which you can then export as an STL object or whatever. This is a paid app, so if you can afford it, get it. It really helps. Now, this is how I use the 3D scan of myself to scale helmets. I usually import the 3D scan into Cura, position it somewhere around the middle of the bed where I know that a helmet will fit perfectly to print, and just slide the helmet over it and start watching it from the far, from below, scale it down, up, go back and forth and see how it looks. From playing around with this, I know already that 96% is pretty good. And the reason why is, if you look down here, you see that there is still some space between my head and the helmet. And the reason why is three things. I need space for padding, I need space for a Bluetooth microphone, and since I'm visiting most of the conventions during hot summer times, I need some ventilation. I did it already in my old helmet, I have ventilation in here, so I have to think about some place for fans. There is another method on how you can scale things, and for that you just take a cross section of your 3D model, print it, see if it fits. If it's not fitting, you scale it up or down, print it again, and do this all over again up until you have a fitting piece. Now, how do you do the cross-section thing? For that, you go into MeshMixer, import your 3D model, and for the helmet, for an example, you take the tightest spot, which is at the cheeks. We are taking the plane cut option. So you go on the left side, press edit, take the plane cut and move it down towards the cheeks, right where they are at tightest. Somewhere like here is pretty good actually. Simply press slice and keep both. And you do the same again, another plane cut, go further down, maybe right here, and do another cut. Now all you gotta do is select separate shells, and then you will see that you have this perfect middle piece, which then you can print. You select it, press export, and export it as cross-section helmet 2 in my case, and bring it into Cura. This is the piece in Cura, print it, try to fit it. If it's too big, make it smaller, or the other way around. Go back and forth up until you have the desired size. It's gonna save you a lot of filament doing it this way instead of printing your whole helmet. Believe me, I've done it, and it's gonna just waste your filament away. Let's talk about slicing and 3D printing. First things first, the hardware that I'm using. I'm using two Creality CR10 V2s, both sitting in the back there. The first one I got approximately 3 years ago when I got into 3D printing and I knew I want to do cosplay. And the other one I just bought recently, secondhand, and the guy who sold it to me didn't use it at all, so it's basically factory fresh. Now, as I said, I chose those printers because I knew I want to do cosplay and print big armor. They come with a bed size of 30 by 30 by 40 centimeters, which allows you to one-shot big prints like helmets and other stuff. The only thing that I didn't one-shot was this beautiful Jetpack here, or the Rising Phoenix. You don't need a big printer though to make cosplay. You can also print everything on smaller print beds. You just have to cut them, make them in smaller pieces, and then add them together later. I've seen people doing whole Iron Man costumes on an Ender 3, so everything is possible. Now let's get to the slicing. As you've seen, I'm using Cura, and I have two profiles, one from my Creality CR10 with a 0.4mm nozzle, and the other one is the one with a 0.6mm nozzle. I don't change too much in the settings. Z seam relative is on, and then I have the infill pattern gyroid. I'm changing the infill density, however, always somewhere between 10% and 20% depending on what I'm printing. For the material, I'm using PLA plus, so it needs a little bit higher temperature. I'm using 210 for the printing temperature, and the build plate temperature is at 60 degrees. For the print speed, I just change it to 55 instead of 50. Not a big deal. You can also print it at 50. For the support, I'm using the normal zigzag support. I'm doing it everywhere usually. The support density is somewhat between 1% and 5%, just to make sure you can get rid of the supports without destroying your 3D print. The most important thing, however, is the build plate adhesion. For that, I always use raft, and the reason why is I want the prints to survive. In order to make them survive, you want to have them stick on the bed really good, and raft is giving you, in my opinion, the best possible way to do that. Let's get to the slicing process itself. For this helmet, for an example, I've scaled it down. I know it's at 96%, it fits my head, and as you can see, it's trying to generate support in the middle of the dome. And in fact, you don't need it for this kind of helmets. So what I'm going to do here is adding a support blocker right in the middle, and then just scale it up with the non-uniform scaling. Make it so it doesn't generate support at that position. Just like this. Something like that. Now all it's left is to press slice, and after a while you will see it's gonna take around about 2.5 days, 2 days, 19 hours to print a helmet like this. It's gonna take roughly 719 grams of filament, which is around about 17 or 18 euros in Germany, which is fine for a helmet like this. Every time you slice something, go into the preview, check through the layers if there's some issues, because you don't want to find out while you are printing. You can go and find it out now. And if something would be wrong, you can reposition the model, slice again, and then save to disk and print. This is the old armor, guys. All of the parts that I did, I had no shin piece for this one here. As you can see, the chest is broke. It's broken in multiple places. The abs broke in half. The paint is starting to come off. Overall, I was really happy with this result, but the next armor is gonna be much better. I printed the chest and abs piece at 10% infill, which didn't make him as strong as I wanted to be, but we learned we're going to go with higher infill density for the next chest pieces. And also, as you can see, I have some wrapping here on the prints, and this is due to the fact that I did resin smoothing and I left the prints for too long in the sunlight. They started to wrap and to melt. However, I learned from this mistake. I'm now using this UV light to cure the resin for the next resin smoothing job. Now this armor is gonna go and be retired. It was a nice experience, and the next armor is gonna be much better. Here are the new pieces that I have printed. Some small pieces missing though, like the ear caps and the vent piece of the helmet, but this can wait. Also the antenna from the Rising Phoenix is not printed yet, but as you can see, I've already started to do some prime and sand job on that piece. Also on the chin piece, I've completely sanded it, primed some of the other stuff, sanded it again. And obviously the kidney piece, which is done with graphite powder. Every Beskar piece will be looking like this. I'm really happy how this turned out, and I think the effect will be super good. We've already prepared LEDs for the whistling birds, for the other gauntlet piece, and we did some smoke machine preparations for the jetpack. So this is gonna be the hard piece of this armor set this time, and I can't wait to finish this. Alright guys, this pretty much wraps it up for this video. I hope you enjoyed it. If you did so, make sure to hit that like button, subscribe to the channel for the following videos, and if you have any suggestions or questions, make sure to leave a comment down below. Up until next time, this is the way.